Welcome to Street Taking Education. I'm your trainer for the day, Ronak Kapoor. Good evening. And the next topic that comes in number systems is last digit. Several times in most of the aptitude exams, we have this type of question in which we have been asked to find the last digit of the entire expression. That expression would be typically of kind a into b into c into d, and we'll be given the numbers, not definitely a b c d, but we'll be given something like 24 into 35 into 29 into something, and it would be a big expression, and we'll be told to find the last digit of the final result. And in other cases, we'll be given the number, one single number, for example 16 raised to some bigger power 75. We'll be asked to find the last digit. Even when I saw these questions for the first time, I was very perplexed. How can possibly we find 16 raised to 75? There has to be certain rules to this, and definitely that's what we are going to discuss today. Consider this basic sums of finding out the last digit. Consider this first example that we've got over here, 4 into 6. This is the very basic thing. 4 into 6. What would be the last digit? We know that 4 into 6, the multiplication would be 24. So only 4 is material to us. We need only 4. The answer would be 4. Similarly, expanding this very example further, we have 4 into 6 into 3. For finding out some bigger numbers like this, 4 into 6 into 3, we don't need to exactly calculate the real value. What we need is 4 into 6, that is 24. So for time being over here, I'll ignore this 2, and I'll take only the last digit that is there, 24. I'll consider 4. 4 into 6 is 24. I'll take the result 4 and multiply it by 3. I'll get the answer 12. So the last digit over here I'll get as 2. I can ignore all the higher digits and consider only the units place of the number. And again, expanding this example further, that is 4 into 6 into 3. I've expanded the same our example with further few more numbers. 4 into 6 into 3. We have seen that 4 into 6 is 24. 4 into 3 would be 12. 12, again take 2. 2 into 7 would be 14. Take 4 and multiply it again by the next digit, that is 4. 4 into 4 is 16. So all we need over here is 16. This is our answer. Similarly, let it be any higher number. Even consider in the bottom this example. Over here, even in among all these digits, we have to consider that is 1456, may it be 653, how much ever bigger the number be, we have to consider only the last digit, that is 4, 6, 3, 7 and 4. All the other numbers are immaterial to us. The procedure remains same like the previous sum. In the next example, this is a special case. Whenever as a last digit you see a 0 among all the numbers, see over here we have got a 70. So 70 is nothing but 0 in the end. So when we are multiplying any number by 10, we know that in the last digit would be 0. When you see 0, click on 0 and click next button. Here I have given some few examples. You pause the video and try to solve it. Now the next part that comes is cyclicity. Cyclicity is a little bit higher version of what we did now. The typical sum in cyclicity, there would be some number like 16. 16 raised to 75. What I discussed just now, 75. There are certain rules with which we can find the last digit of these numbers. Now consider any numbers ending in 1, 2, 3, 4 and 5 and so on. Whenever these numbers are ending in the last digit, factors that affect the last digit is only the units place of the number. So if I have something like 16 raised to 75, I know that it is 16 into 16 into 16 into 16 75 times. So rather than going 16 into 16 and calculating the last digit, we'll use certain shortcuts. Now let us start with the number 1. Whenever number is ending in 1, let us consider the example of 11. And we have got a power, say 11 raised to 3. We have the last digit as 1 into 1, which will remain 1, and into 1, which will remain 1. So going on further, in all the powers of the units digit would remain 1. And consider the next case, that is 2. We know that 2 raised to 1 is 2. 2 raised to 2 would be 2 into 2, 4. Then again when one more 2 would come, it would be 4 into 2 is 8. 8 into 2 would be 16. And further multiplying 16, 6 into 2 would be 12, 2 into 2 would be 4, 4 into 2 would be 8. Next number 3, we have 3, 3 into 3 9, 9 into 3 7, that is 9 into 3 27, so we'll take only the unit digit part, and 7 into 3 would be 21 1. Then again 3, 9, 7 and so on. Similarly, take the case of 4, 4 raised to 1 is 4, 4 into 4 would be 6, 6 into 4 would be 24, then we'll again multiply by 4 6. So you'll see that 4 6 4 6 pattern is going on repeating. And next number that comes is 5. 5, all the powers of 5 will have the last digit as 5. Because 5 into 5 25, to again multiply it by 5 we'll get 25. So in cases of 1, 5, 6 and 0, all the digits remain 1, 5, 6 and 0 respectively. And going on further, I'll take the example of 7. 7 raised to 1 is 7, 7 into 7 49, 9 into 7 63, 3 into 7 will give me 21, then again into 7 7, again into 7 41, and the cycle goes on repeating. For all the digits, if you notice, let me draw a line over here. After every 4 powers, that is, let us consider the number 2 over here, let me put it as 22. So 22 raised to 1 raised to 2 raised to 3 raised to 4, then again 5 6 7 8. After every 4 digits, this number goes on repeating. 2486, 2486, 2486 will go on repeating. So can I not say that the unit digit, when the power is 1 and 5 and 8 plus 1 and 12 plus 1, after every 4n plus 1 the powers will remain same? Similarly, for the case of 4n plus 2, for the powers 2, 6, 10, 14, all the powers will remain same, or the unit digit for all these powers will remain same. In an underline of this, we need to break this power, the 75, in the form of 4n plus either 4n plus 1, 4n plus 2, 4n plus 3 and 4n plus or 4n plus 4. We have to find the remainder basically after dividing the power by 4. So consider, before considering going on to 75, let me take the example of 15. So I know 15 is 4n plus 3, that is 4 into 3, that is 12, 4 into 3 12 plus 3. So if this number 12 is raised to power 15, so I will take this case. So whatever the number is corresponding to 2 over here, that would be the unit digit. Similarly, take up another example. 16 raised to 75. So we know that for all the powers ending in 6, 6 is ending in 16. For any power, it is the last digit is 6. So that would be the answer. 6 is the answer. We don't need to practically calculate 4n plus 1 in cases of 1, 5, 6 and 0. But in other cases of 2, 3, 4, 8, we always need to break the power down into form of 4n plus something. 4n plus 1, 4n plus 2, 4n plus 3 or 4n plus 0. And remember this, that whenever you you make it as 4n plus 1, this one part will decide whether you are taking the power as raised to 1, raised to 2, raised to 3 or raised to 4. 4n plus 4 is 4n plus 0 is nothing but 4n plus 4. Now let us take a few examples. How do we exactly break this number, break the power into 4n form? Here we have taken the example of 67 raised to 26. All we need to consider over here is last digit of the base number and the form of the power 26. Step 1 is we have to break the power in the form of 4n plus 1 form, 4n plus 1, 4n plus 2, 3 or 4, and then see the last digit of the base. 26 plus 4n, 26 is equal to 4n plus 2. Multiple of 4 is 24, and after 24 we have to count 2, 25 and 26, that becomes 2. So we have to just check the power of 7 square, 7 raised to 2, and we get the answer as 49. Other examples are 3 raised to 9, 33 raised to 9, 4 raised to 6 or 34 raised to 6. Now whenever the number is 3 raised to 9, even at that point we have to just see the last unit digit and just break the power, that is 9, in 4n plus 1 form. And be it 3, 33, 43, 493, 1100, 253, that the final answer remains immaterial. We have to just see the last digit. This last digit is important. Rest all other digits are not important, and we have to break this down. 9 into in the power of 4n plus 1. Over here also 4 is to 6. The 4 and 6 will remain 4n plus 2 form, and 34 same procedure. And even in this case 334, it remains the same procedure. And in the last example we have got 8 raised to 78. We just need to see the last digit, that is 8, and break down 78 in the form of 4n plus 1 or 2. When we divide it, so we have got the last digit as 8 square 64. The answer will be 4. Take up a few examples on your own and try to check the numbers of what the last digit is. And thank you for being with CET King, and in other videos we will have different topics covered. Thank you.